Okay, so for number one, explain to yourself in your own words what are the key takeaways from the video. So the speaker basically talks about how wind-ups occur as the saturation point is reached for PID systems. So to put into a simpler perspective, we can think of it as what he exemplified, motor, and this motor in its real life capacity would only spin at max at 1000 rpm. However, when the integrator's commands output exceeds 1000 rpm, let's say for example it reaches 2000, and when it starts to decrease yet is still above 1000 rpm, then the real life motor would still spin at 1000 rpm. So even if it's decreasing, it's still spinning at max rpm and it's going up. So we should really take into account that once it reaches 1000 rpm, we should take into account outputs below 1000 instead of letting it be situated at the saturation point. So to fix this, he talks about anti-wind-up systems for PID controllers, and he particularly talks about clamping, which he defines as the integrator turning off through a switch. So as it goes to 1000, it then wouldn't exceed 1000, and it would only reach a max output of slightly below 1000, and it then begins to decrease. And for number two, was the video helpful in giving you more understanding of the subject? Yes, it was definitely helpful because this is honestly the first time I've heard about such a situation, and it definitely makes sense that this truly happens because of course our outputs could be beyond what's like realistically capable of what our device can do. So we definitely have to address that so that even if the integrator decreases, it's still above what the device can realistically do, then the device will still be at max performance. So we really have to find ways to limit this scenario. And as a future engineer, what are some interesting insights you gained from the topic? So I definitely learned how there should be a limit, and with how we shouldn't let our outputs exceed what is physically and realistically possible for a device to perform. So we should definitely set limits through, once again, processes such as clamping, and that is all.